All right, so today's focus question is if a triangle with side lengths A, B, and C satisfies the relationship of the Pythagorean theorem, a squared plus b squared equals c squared, is the triangle a right triangle? That's what we're going to discover today. So it says in this problem you will explore these questions about the opposite or converse of the Pythagorean theorem, meaning if we're given three sides, how can we test it to make sure it's a right triangle or not? And again, we did this in our doodle notes. All right. So if we take the very first one, right, which is a 3, 4, 5 triangle. Let me dial down my pen here just a minute. Okay. So 3, 4, 5, right? We know that the side A is what of a triangle? Side A is the smallest side. So sometimes it helps to label them. Okay? So if 3 is the smallest side, what's the biggest side? What letter? C, right? And 5 is the biggest side, right? Which means this is B. All right? And again, my board is off again. So even though I'm recording, I'm going to quickly just orient this thing really fast because it's driving me crazy already. And it's a Friday, and I do not want to be driven crazy on a Friday. All right, so once we label them A, B, and C, let's just plug them into the formula. So 3 squared plus 4 squared equals 5 squared. And now you've had a little exposure to this. Hopefully you know right now that what that triangle is. So 3 squared is 9. 4 squared is 16, and 5 squared is 25. So when I add the left side together, does 25 equal 25? Does it? It does. So that means that, yes, this is a right triangle. Because we got the legs, the sum of the squares of A and B, the legs, equal the sum of the square of the hypotenuse. So yes, that is a right triangle. So what we're going to do is we're going to try to do the first three together, and then I'm going to let you guys kind of experiment a little bit here. So let's do the 5, 12, 13. So 5 squared, because that's the smallest side, right? So side A, what's the biggest side? 13, that's C, so here's B, right? So 5 squared plus 12 squared equals 13 squared. So 5 squared is 25. What's 12 squared? 144. And what's 13 squared? So when I add 25 and 144, we get what? Does 169 equal 169? Sure does. That means, yes, this is a right triangle. Because, again, the sum of the squares of the legs equals the sum of the square of the hypotenuse. All right. So if we try 5, 6, and 10, all right. So again, smallest side is here, biggest side is here. There's the medium side. You know, sometimes they don't always put this in order for us. So again, it's important that we identify that. And by just putting A, B, and C over the right numbers, it makes life easy for you plugging things in. So here we got 5 squared plus 6 squared equals 10 squared. So what's 6 squared? 36. And 10 squared? So when I add 25 and 36, I get 61. Does 61 equal 100? No. So since the sum of the squares don't equal the square of the hypotenuse, this is not a right triangle. A big old no. Okay? All right. So 6, 8, 10. So what's our smallest side? Biggest side? Okay, once we got them labeled, plug them in. 6 squared plus 8 squared equals 10 squared. I got 36 plus 64 equals 100, right? Because 8 squared is 64. So when I add 36 and 64 together, I get 100. And 100 equals 100, right? So yes, this one's a right triangle. Again, because the sum of the squares of the legs equals the square of the hypotenuse. What do you think about the next one? Do you think the one's at 4, 4, 4? Do you think that's going to be a right triangle? Why do you think that? Right. Not only that, we don't even have a longer side here, do we? They're all the same side. So when I just do so if I just plug in 4 squared plus 4 squared equals 4 squared, I get 16 plus 16 equals 16. So 32 doesn't equal 16. And the reason it can is because you're basically taking two sides that are the same length and squaring them only against one side that's the same length and it's only squaring that. So that is not a right triangle. Again, because the sum of the squares of the legs don't equal the square of the hypotenuse. All right, what about a 1, 2, 2? Well, if we square 1, but see, I got two of the same sides here, so I really don't have a biggest side, do I? So when I plug this into the formula, I get 1 plus 4 equals 4. So I get 5 equals 4, which is not the case, right? 5 does not equal 4. So this is not a right triangle. And again, the biggest things about these two is there's not a longest side. Remember, in a right triangle, the side C always has to be the longest side. I don't have a longest side here. In the first one, all the sides were the same. Right? Isn't that an equilateral triangle? The second one, I had two sides that were the same, that were the biggest length. So again, in those two triangles, I didn't have one side that stood out as the longest side. Okay? So it wasn't going to work. All right. So sides that satisfy the relationship a squared plus b squared equals c squared form a right triangle. And then again, sides that do not satisfy that a squared plus b squared equals c squared do not form a right triangle. So that's what we saw from our table. So here's what I want you guys to do with your team. I want you to kind of divide and conquer. Okay? And since everyone has 4, so that's for one table, I want you to take 1, 2, and 3. Forget 4 right now. So with 4 people, you might have to share one together. Is I want you to take, each person takes 1, 2, and 3. So one of each. And see if these are right triangles or not. Determine whether a triangle with the given lengths is a right triangle. And then we'll do 4 together. All right? So how about 1s, you take number 1, 2s, you take 2s, 3s, you take number 3, and 4s, you can help out with whatever the most difficult one is. Or what you guys think is the most difficult. You guys can kind of play rover and kind of help all 3 of them. All right, so we're going to quickly pause this and give you guys a few minutes. All right, so let's see what we came up with. So, excuse me. So again, plugging these in. Which one is side A? 12. I only want to hear from the ones right now. Side B is right here, right? Because 20 is the longest side. So again, 12 squared plus 16 squared equals 20 squared, right? Well, we know what 12 squared is. So number ones, what is 16 squared? Huh? 256. And 20 squared is? 400. Brad, when I add 144 and 256, what do I get? So 400 equals 400, right? So what happens when the sum of the legs equals the sum of the hypotenuse, the squares? It's a right triangle, so this is a yes. So A was a yes. Or number 1, I should say, sorry. All right, 2s, I want to hear from you, right? What was our biggest side? 17. Our smallest side was 8, so this is right. So 8 squared plus 15 squared equals 17 squared. So 8 squared is 64. What was 15 squared? 225. And what's 17 squared? 289. And when I add 64 and 225 together, what do I get, 2s? So we get 289 equals 289. So that means, yes, those are sides of a right triangle. Because again, the sum of the squares of the legs equals the sum of the square of the hypotenuse. So this is a yes. 2 for 2. All right, threes. Threes. Where's it? What's our shortest length? 9. Oh, they changed the order on you. Okay, what's our B? And then our C is 16, right? So 9 squared plus 12 squared equals 16 squared. And 16 squared was what again? 256. All right, 3. So if I add 81 to 144, what did you get? We get 225. Does 225 equal 256? No, so what do we know, threes? Yeah, it's not a right triangle. Those are not sides of a right triangle. So that's a no. All right, so Diego says that he knew one of the above triangles would be a right triangle. It is a scale of one of the right triangles in question A. Okay, that's up above. So, do you agree with his thinking? One of these triangles was on a different scale than in question A. Do you know which one he's talking about? So one of those triangles in this table, right here, up above. I guess you can say one of these triangles, he's saying, was on a different scale. It is a scale copy of one of the right triangles in question A. So one of these guys. So think of things that could be equivalent, I guess you could say. Anyone see it? Angelina, you think you see it?
But 12 and 16, 6 and 10 isn't that half of those numbers?
Which one? Up top?
Yes, 6, 8. Wait, of 12, 16.
Yeah, so I guess you can call this number 4. Right? Right? Number 4. And she's comparing it to number 1 and down here in C. Isn't 6, 8, and 10 half of these numbers? Half of these numbers in number 1? Right? Half of 12 is 6. Half of 16 is 8. Half of 20 is 10. So that triangle is half the size of that one. Because those numbers were half of, right? Or you had to multiply each by 2 to get to the same. So it's half the size scale. This is double the size triangle that the number number 4 is, right? All right, very good. All right, so your homework, yes there is right here. Maybe I'll try to make this a little bit brighter. There we go. Four to 6 and 27. All right, we're going to shut down our video here for a second.